So good morning. Is it still morning? Yeah. Good morning, everyone. Happy to be here today. And Psigryph is a 2018 incorporated company. We're spun out from the University of Guelph, and we are using, which is the biggest ag school in Canada, and we are using our plant-derived, non-toxic biotechnology, nanotechnology, to improve the health of plants, animals, humans, and the planet. There we go. So just, again, a quick introduction. So we're an agri-food biotech company. We have a patent-pending technology. It's been filed in a dozen countries around the world. And we have a number of potential applications for the technology, and we're pursuing all of them in sequence from the least regulatory resistance to the most regulatory resistance. We're in advanced discussions with a couple of large corporates. One is testing our technology in their R&D facilities today, and we're looking forward to feedback from them in the near future. We ran and that is in the agriculture space. We ran a pilot with a food company, and I'll talk a little bit more about what they've asked us to do in terms of the next steps. But our first revenue-generating product is in the middle there at the bottom, Cholesterol. It's a dietary supplement intended for humans. It's the first sort of application of the technology, and it was very effective at lowering cholesterol in animal models. So the problem that our technology is solving is poor bioavailability. It's this concept of getting molecules of interest inside a living cell. And this is a problem for pesticides, it's a problem for fertilizers, animal feed, and pharmaceuticals, as well as nutrition for human and pharma. So it's biologically the same problem. It's just the payload molecule that determines what the effect is. So I think I'll skip over this slide. And essentially, our technology, NanoPect, is like UPS for living cells. So we're simply a packaging material that goes around a molecule that you want to get inside a cell very efficiently. The technology is derived from sour cherries. We grow a lot of sour cherries in Ontario. And so that's why one of the crops that was studied was sour cherries. We actually discovered these nanomaterials in grapes first, but then for cost and productivity reasons, focused in on sour cherries. So they're subjected to a proprietary process to create these spherical nanoparticles and then string-like nanofibers, and then we attach payload molecules to make final products for ag, food, or nutraceuticals, pharmaceuticals. So I mentioned Cholesterol. This will be going into the market in the United States later this fall. And we have several transnationals looking at the initial sales of this product. So I expect we'll enter into a licensing agreement when this product takes off. And so this problem of nutrient deficiency is, all of these things are related to nutrient deficiency. So we think we can solve a lot of these problems with dietary supplements. And we're going after high cholesterol first because that's where we have traction, and that's where we have data. So, but the solution is the same. We start with the sour cherries. We make a powder out of a blend of ingredients to improve some sort of health function. And these are the data that we saw in the animal model. So the dotted line at the top is Lipitor, the top-selling statin drug in the same model where it lowered cholesterol by 20%. This product lowered cholesterol by 50%. So we know there's a large market for this, around a $200 million product, potential peak sales in the United States. Now let's talk a little bit more about agriculture. So most of our R&D is focused on agriculture.